This week's lesson focuses on similarity in right triangles. In a right triangle, if I draw an altitude from the vertex of the right angle to the hypotenuse of that triangle, it forms two more right triangles. Those two triangles are similar to one another and to the original triangle. If I look at this picture here, ABC is my original triangle. I draw an altitude, and remember, an altitude forms a right angle. So once I draw that altitude, I form two more right triangles. Since an altitude makes a right angle on this side, I will also have a right angle on this side. This gives us three triangles: the original large triangle, the big one on the right, and the small one on the left. These three triangles are similar, and I can name them as such. So if I look at this first triangle, A, B, C, B is where my right angle is. And I never cross over the hypotenuse when I name this, A, B, C. It goes from the long side to the short side. So if I look at the next triangle, the large triangle here, BDA, well, the first thing I want to do is go across the long side to the right angle. Well, I know D is my right angle. The long side would be ADB, so I name it as such. And then same thing with the small triangle. My right angle's at D again. So the long side, BD, the short side, CD. So BDC will be the name of that triangle. So let's write a similarity statement comparing the three triangles in the second picture. So the first thing I'm going to see is that I have my original triangle UWV. I'm going to name it the same way, going along the long side to the short side and ignoring that hypotenuse. UWV. So triangle UWV. And that W is where the right angle is in my large triangle. If I look at the triangle on the left, I have a right angle here. So I want to look for the long side to the short side. And the long side of this triangle, not the hypotenuse, because I'm ignoring the one across from the right angle, would be UZ, right angle is Z, and go up to W. So this will be similar to triangle UCW. Again, that right angle is Z, and I always want that right angle in the middle if I'm naming it that way. I want it in the same position in the first triangle, the second triangle, and whenever I write it in this third triangle. So the third triangle, that would be similar to, again, I have this small triangle over on the right-hand side. I've got my right angle. I'm going to ignore the hypotenuse. The long side of this triangle will be WZ. So WZ, Z is the right angle, V. So we wrote a similarity statement comparing those three triangles. Our second concept of this lesson is a geometric mean, and eventually you'll see that both of those concepts will come together. So if I consider the proportion A over X equals X over B, in this case, the means of the proportion are the same number, and the number is the geometric mean of the extremes. The geometric mean of two positive numbers is the positive square root of our product. So the geometric mean of A and B is the positive number X, so that X equals the square root of AB. So let's find the geometric mean of these two numbers, 4 and 25. Those would be my A and B, because X is the geometric mean. So what I need to do to find X is to take the square root of the product of 4 and 25. Well, 4 times 25 is 100, and the square root of 100 is 10. So the geometric mean of 4 and 25 is 10. We can do the same thing here, A, B. So the geometric mean is the square root of the product of 5 and 30. 5 times 30 is 150. And the square root of 150 is about 12.47 Or if you just wanted to round to the 10th place, we could do 12.5. So let's combine those two concepts to find the geometric mean with similar right triangles. So the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So if I look at this picture, I can see that the altitude of my triangle is h. And that altitude splits my hypotenuse into two parts, x and y. So if I were to multiply x and y together, I should get h squared. I could also write this as h equals the square root of xy. So if I look at this example down here at the bottom, I see that my altitude here is 6. That altitude splits my hypotenuse into two parts, x and y. So let's look at that equation. H squared equals x, y. Well, again, that height, that h, is my altitude, so I'm going to replace that h with 6. X stays x, and y is 9. 6 squared is 36. 9 times x is just 9x. And to get x by itself, we are going to divide by 9 to get your x value equals 4. So let's look at a word problem. To estimate the height of a Douglas fir, Jan positions herself so that her lines of sight to the top and the bottom of the tree form a 90-degree angle. Her eyes are about 1.6 meters above the ground, and she is standing 7.8 meters from the tree. What is the height of the tree to the nearest meter? So she is positioning herself so her lines of sight form a 90-degree angle. What that is telling us are that here, Jan forms a 90-degree angle, the top and the bottom of the tree, which means this is my altitude, my h, which would split this side, the hypotenuse, into two parts, x and y. Let's label the height above her eyesight as x and the height below her eyesight as y. So if I go back to my equation, h squared equals xy. I know h is 7.8. I don't know x, but I know y is 1.6. So I need to take 7.8 squared to get 60.84 equals 1.6x. To find x, I will divide by 1.6. And I get x equals 38.025, which I'm just going to round to 38. So I know the height of the tree above her eyesight is 38 meters. I want to know what the height of the tree is. So I'm going to have to add my x and my y, the height above her eyesight and the height below her eyesight. So if I add 38 meters plus 1.6 meters, I will get about 39.6 meters. That tree is about 39.6 meters tall. And that's the end of our lesson for this week. Remember, if you have any questions, be sure to ask your teacher and keep up to date with all of your schoolwork. Hope to see you again next week.